All right, we had discussed the three forms of an equation. So today we're going to talk about converting from one form to the other. So we've got the vertex form of a quadratic, the factored form of a quadratic, and the standard form of a quadratic. We did talk about what each one of those gives us in terms of graph attributes. The h and the k were the vertex on the vertex form. The a was the concavity. On the factored form, the a is the concavity. The R1 and R2 are the roots, so it gives us our two x-intercepts. And on the standard form, the C is the y-intercept and the A is the concavity again. With each one of these equations, we have some unknowns. So with the vertex form, we would need the vertex to write the equation, so the H and the K, and then we would also need the A value. So there are three unknowns. With the factored form, we again have that A value we need, and then we need our first root and our second root. So there's also three unknowns. And with the standard form, we are missing the A, the B, and the C, which is the y-intercept. In this case, three unknowns again. In order to write the equation of a quadratic, you need those three unknowns. Here is a brief set of notes that we'll talk quickly through. To get those three unknowns, if you have a vertex and a point, you are able to write that equation because the vertex is h, k. So 5 would go in the place of the h and 2 would go in the place of the k here. The last thing we would need is that a value, the third unknown. Well, we can get that from the ordered pair because an equation is every single ordered pair on that graph. Then this x value and y value can be plugged in. I can plug in the 9 for the y and the 4 for the x. I then go ahead and solve for the a value, and I end up with a is 7, so I can plug that in for the equation, and we get y equals 7 times x minus 5 squared plus 2. The same is true for the factored form. In the factored form, if we're given the two roots, then they have given us R1 and R2. So we can plug that into our equation to be x minus our first root and x minus our second root. Once we have the roots in, we can use this additional point again as an x comma y so that we can plug it in and solve for the a. And so I take that -2 and I plug it in for the R1, I take the 4 and plug it in for the R2. I take 1 and plug it in for X, and then the 6 and plug it in for the Y. The only thing that's left is A, making that a one variable equation. The 1 plus 2 gives us 3, and the 1 minus 4 gives us -3. We multiply those together to get -9, and we divide and get -2/3. So then my final equation would be the -2/3 we got for A, X plus 2, X minus 4. With the standard form, we will get to that in a little bit. That's not quite as easy to get the A, B, and C. Now, the first thing you're going to want to do when you're given information is to decide which one of those would be the best to write them. So here is a couple examples we'll just run through. They gave us a minimum point of 6, -75, and a y-intercept of 0.15. The y-intercept with the standard form, remember, that doesn't really help us as much as we want because that's only the C value, so I would still need A and B. However, by giving me the minimum point is the vertex. So if they have given us the vertex and another point, the best form to write is the vertex form. For the second one, it says it gave us the points 2, 0, 8, 0, and 4, 6. You have to recognize that since the y value is 0 on both of these are roots. So they have given us the roots, and then they've given us an additional point, so the factored form would be the best to write. On our next one here, we have 175, 455, and 75, and 150 and 95. These are not roots, they're not a vertex, they're not any of those, so we can't use the vertex or the factored form. So in this case, we would want to do a standard form, and you can write a system of equations in order to get that. And again, we'll get back to that in a little bit. On our next one here, we have 3, 3, 4, 3, and 5, 3. As you think about these points, all three of them have the same y value, so there's no way that this is a quadratic. The y value can only be in two of them for it to be a quadratic. This is probably a horizontal line, so this would be in none of those for the quadratic form. Here they're telling us they're giving us the x-intercept for these two, and then a point at -4 and -4. Again, the x-intercepts are the same thing as the roots, so the factored form would be the best one there. Our next one here, roots and a point, so that would be factored form again. Now we'll look at some quick application problems just so we can determine from that. It says Max hits a baseball off a tee that is 3 feet high. The ball reaches a maximum height of 20 feet when it is 15 feet from the tee. So there's different information you're going to want to think through here. The easiest one to point out, anytime they're telling you a maximum height or a minimum height, you know that's the vertex. So they have given us a vertex. By telling us that it was hit 3 feet high, they're giving us the y-intercept of 0, 3, because that's where it started. But when they give us the vertex form is definitely the best one. All right, so for the last one, it says a grasshopper was standing on the 35-yard line of a football field. He jumped and landed on the 38-yard line. At that 36-yard line, he was 8 inches in the air. So if he was on the ground when he jumped, at the 35-yard and the 38, they have given us the roots. And when they give us the roots, the factored form is the best one to write it in, because we do have another point there to find the a value. All right, we're going to go a little bit deeper with that on our word problems in the back here. It says, the Amazing Larry is a human cannonball. He would like to reach a maximum height of 30 feet during the next launch. Based on Amazing Larry's previous launches, his assistant DeJuan has estimated that this will occur when he is 40 feet from the cannon. When Amazing Larry shot from the cannon, he is 10 feet above the ground. Write a function to represent Amazing Larry's height in terms of his distance. So we're going to want to really think about what information they're giving us about the quadratic here. So I'm going to go ahead and draw our cannon here. And draw a picture just so you see what is happening. Here is Larry being shot from the cannon. And then gravity takes its pull and he comes back down. It tells us that when he's at his starting point right here, he is 10 feet off the ground. So that gives us our y-intercept of 0, 10. That's his starting point, and he's 10 feet off the ground. The next thing it tells us is that when he's 40 feet from the cannon, he's 30 feet in the air. And when he is he's 40 feet from the cannon. Tells us right here that that was his maximum height, so we know that's the vertex there. Now we want to think about some other information that they give us just to make sure we have everything that we need here. So they gave us the y-intercept at 0, 10. They gave us the vertex at 40, 30. So the best equation to write here is the vertex form, and we could do that. Now remember that quadratics are symmetrical, so right here would be our axis of symmetry. It cuts right through the vertex always. And so if it went 40 this way to the vertex, then it also needs to go 40 on the other side. So we've also got the point here at 80, 10. So you do have 3 points there that they have given us to write this equation. So to start this equation, I said the vertex form is the best one. So that is a times x minus h squared plus k. There's my vertex form. Now I'm going to go ahead and plug in my h and k, which are my vertex, 40 and 30. So I get x minus 40, which is my h, squared, plus 30, which is my k. To find that a value now, I want to use either one of these points. Any point on the graph is going to give you the same exact a value. So you can pick whichever one you want. I think this will be easier, so I'm going to go ahead and plug that. I plug in 10 for my y and 0 for my x. And now we're ready to go with solving since there's only one variable there. I'm going to subtract the 30 to get it to the other side. That gives me negative 20 is equal to a times, and negative 40 squared is 1600. I then divide by 1600. And then we can reduce that to negative 180. So now that I have my a value, I know what my equation is. Negative 1 over 80 times x minus 40, which was my h, plus 30, which is my k. There's our equation for Amazing Larry's jump. Shot out of the cannonball. All right, so for this next one, it says Crazy Cornelius is a fire jumper. He is attempting to run and jump through a ring of fire. He runs for 10 feet, then he begins his jump just 4 feet from the fire and lands on the other side, 3 feet from the fire ring. When Cornelius was 1 foot from the ring of fire, the fire ring, at the beginning of his jump, he has 3.5 feet in the air. Write a function to represent Crazy Cornelius' height in terms of his distance. There's some confusing way that they wrote that there, so drawing a picture may be the best way that we can do this. So here is our ring of fire. And I am not your art teacher. Here is his run. So it says that he runs for 10 feet. He then jumps through the ring of fire and lands on the other side. So let's talk about the rest of the points. So we know this point right here is at 10, 0, because he has not jumped yet, he's ran those 10 feet. The next one says that he begins his jump just 4 feet from the ring of fire. So we know that this is 4 feet to that ring of fire. And lands on the other side 3 feet away. So there is another 3 feet. So this point would be at 17, 0. So we've got our 2 roots there. Now it says when Cornelius was 1 foot from the fire ring at the beginning of his jump, he was 3.5 feet in the air. So when he is 1 foot from here, we're talking about this point right here. And the ring of fire was 4, so that was at 14 right here. So this one has to be at 13. He was 3.5 feet in the air. So there is all the information they've given us. Now that we have that, we know we've got the 2 roots that they gave us, and then we have an additional point somewhere on the graph. So factored form would be the best way to write this. For the factored form, that is a times x minus r1, x minus r2. Now we're ready to write this equation in the factored form. So I start by putting in my roots. So that's x minus my first root, which is 10, x minus my second root, which is 17. We still need to figure out what this a value is to make it its quadratic. So we're going to take the points from this xy value, plug them in to find that a. So I plug in 3.5 for my y and 13 for my x. It's time to simplify this a little bit. So in this first parentheses, I get a 3. In this second parentheses, I get a -4. I multiply that together and I get -12a. We divide by -12. You're just solving at this point for our unknown variable. And so a is equal to -7/24. And so our factored form is -7/24 is the a value, x minus my first root, which was 10, and x minus my second root, which is 17. There's our equation in the factored form. So given a vertex and a point, you should be able to write the vertex form. Given your roots and a point, you should be able to write your factor form. All right, we've talked about writing the equation now from those points, given the roots and the vertex for an equation. We want to talk about converting from one equation to the other. Now we've converted from the standard form to the factored form by factoring, so that one's one that you should be able to do. But one of the harder ones is going from the standard form to the vertex form, but it's an important one that you want to be able to convert from. In order to do that, you have to be able to complete the square. So we're going to quickly review how you complete the square. We've got some diagrams here at this point so that you can see what a perfect square trinomial looks like. That's x plus 4 squared. If you remember, that's a pretty crucial part of the vertex form, is for it to be in this perfect square trinomial form. In order for it to be a perfect square trinomial, it needs to be factored that way. It needs to be a trinomial that looks like this, with this missing piece of c, making it a perfect square. So we're going to show you with the algebra tiles here first, and then we'll move to the algebraic part. So x squared is this bigger tile, and each x is this rectangle tile, and then a constant would be the small little square. If we set up what we know here, x squared plus 2x, we would have x squared, and then I went ahead and put one of the rectangles on each side. Then what's left is just 1 to make this a perfect square. So my missing term would be 1. And so we've got y equals x squared plus 2x plus 1 would be our perfect square trinomial. This can be written as the factored form, x plus 1 and x plus 1. When you think about factoring this, what multiplies to be 1 and adds to be 2? Well, that's x plus 1 times x plus 1. We see that on the sides here as well. And so it can be written x plus 1 squared. And so x plus 1 squared is equal to x squared plus 2x plus 1. All right, so to find the missing piece, and we just did that with this one, we took half of these and put them on one side and half and put them on the other side to make this perfect square trinomial. And then when you multiplied whatever was there, gave you that last value, the c value here. So for this middle one, if we took half of 4, that would be 2 on each side. And then when we multiplied 2 times 2, we got the 4. So our number needed to complete the square would be 4, and it would be x plus 2 squared, so since we put 2 on each side. If we had 6 x's, we would take 3 of those and put them on each side. And then 3 times 3 gives us 9. So our missing term would be 9. And since we put 3 on each side, that's the x plus 3 squared. All right, so here's in general terms so that we can think about where are we getting these numbers from. So we took the middle term and divided it by 2, and then we multiplied it times itself, which is a squaring. So this missing term is b over 2 squared, and then it always factored to be x plus b over 2, and then the square on the outside. All right. So we are going to practice that now to write it in the vertex form. And we're going to use that completing the square part in order to do that. I can make this a perfect square trinomial here. I'm going to go ahead and ignore the -7 because I know that doesn't make it a perfect square, since it's 6 divided by 2, which is 3, and squared, which is 9, so it's not that one. So I'm going to start by setting this up, looking for the missing piece here. And I'm just going to move that 7 over to the side. Now, if I add something here, I am changing the equation. So I'm going to have to subtract that same thing from there in order to not change the value of the equation. But I need this to be a perfect square trinomial so that I can factor it to look like this and I can get the vertex form. So 6 divided by 2 is 3 and squared is 9. Now I added 9, so I'm going to go ahead and subtract 9 so that I am not changing the value of the equation. Now we're ready to factor. We know that this right here is a perfect square trinomial, so it factors to be x plus b over 2, so 6 over 2, which is 3 squared. So I factored this part of it. Now -7 and -9 is -16. And so look at that, we are now on the vertex form. Remember that is x minus h squared plus k. So my h there would be -3 and my k would be -16. There we go. So we took it from the standard form, this is a standard form, and we took it over here to the vertex form. My arrow went a little bit long, but that's the vertex form right there. All right, we're going to try that one more time here. And so I am going to find what my missing term is to make that a perfect square trinomial. I'm going to go ahead and leave the 22 on the outside since I know that does not make it a perfect square trinomial. And I'm going to subtract whatever that missing term is so that I'm not changing the value. So we take this middle term of -10 and divide it by 2, which is -5, and square it, which is 25. If I add 25, I'm adding to the value, so I need to subtract that 25. Now we are ready to factor. And so I factor these 3 terms up in the front here, which are my perfect square trinomial. And that factors to be x and then plus this b divided by 2. So -10 divided by 2 is -5. And 22 minus 25 is a -3. It is now in the vertex form. And so my vertex would be 5 and -3. You'll see questions on the test where they give it to you in standard form and ask you for the vertex. That is what you need to do in order to get to the vertex. All right. We're going to get to some that are a little bit harder just to make sure that you can do those with an a value. So there's a little more thought that goes into the ones with the a value. Those are a little bit harder. When I get this set up to do my perfect square trinomial, I'm going to have to factor whatever's in front of the x squared. So I factor out the 2 here, and I get 2 times x squared gives me 2x squared. 2 times -10x gives me that -20x. And then again, I'm going to just put my blank there to make it a perfect square trinomial. And we've got this 52 on the outside there. I'm going to have to subtract from there whatever value I add here. Now the reason why this one takes a little more thought is because when we take this middle term and divide it by 2, so -10 divided by 2 is -5, squared is 25. Now I did not just add 25 to the equation. I added 50 to the equation because that 2 is going to end up multiplying times that 25. So I need to subtract 50 from the equation. I added a value of 50, I subtract a value of 50. Now we are ready to factor. This is a perfect square trinomial, so it factors to be this b part divided by 2, so that's -5. And then 52 minus 50 is 2. This particular one had an a value here. That does not change how we find the vertex. The vertex would be 5 and 2. We'll do one more of those since that one's a little more work. We factor out this 3. And so now we've made this a perfect square, or we're going to make it a perfect square. 3 times x squared gives us 3x squared. 3 times 4x gives us 12x. And then we're looking for what makes us the perfect square trinomial here. So b, 4, divided by 2 is 2, squared is 4. We just added a value of 12 because 3 times 4 gives us 12. So we need to subtract a value of 12. We now factor this part right here, and that becomes x plus 2 squared, since that's a perfect square trinomial. 22 minus 12. And there is our vertex form. And so our vertex would be -2 and 10. So that's how to convert it from the standard form to the vertex form. Now we're going to rewrite it from the vertex form to the standard form. So I want to make sure I go over that as well. And so when we take it from the standard form to the from the vertex form to the standard form, we need to FOIL this out. That means you have to use the box to multiply x plus 3 times x plus 3, or you have to FOIL or distribute. Remember that right there is the same thing as x plus 3 times x plus 3. So however you would multiply that out, you need to do that. Either FOIL, box, distribution, whatever you call it. So we get x squared plus 6x plus 9 now in the parentheses. We multiplied this part, x plus 3 squared. Now we distribute that too, so 2x squared plus 12x when I multiply 2 times 6x, and then 2 times 9 gives me 18.